Hello, this is Mr. McMurray here, and we're here today. Well, actually, you're here today. I am not here. I am gone, but I will be back. All right. And before I go any further, don't let me forget. I don't want to forget there is a quiz on counting the atoms in a molecule and telling whether it's a compound or a molecule, kind of like we did on the worksheet we did yesterday. So don't forget that. That will be on Wednesday when I'm back. But we're going to talk today about naming compounds. All right. We could call them Tom and Jerry and whatever, but there's billions and billions and trillions of compounds. And so we need to have a naming system so we can tell them all apart, okay? And even though there are billions and billions of chemicals, I can teach you about 3 or 4 rules that will help you name most of the chemicals you're about to run into. Now, there are, especially in organic compounds, which are like in living things and stuff, we have some very complicated chemicals in us and our bodies make. But some simple rules will help you name a lot of the chemicals you'll find on ingredients, on food labels, shaving cream, whatever. Anything that has an ingredient label, this will help you understand what you're seeing there at least. All right, so let's talk about naming compounds. All right, so the first rule is a compound made of 2 elements. If there are 2 elements, there are probably going to be 2 types. They are going to be a metal and a non-metal. Because, remember, metals have what kind of a charge? That's right, they have a positive charge, and non-metals have a negative charge, and therefore they very often come together, okay, and make a compound because one's positive, one's negative, just like 2 parts of the magnet, boom, they snap right together. All right, so they're made of 2 elements, a metal and a non-metal. All right, now the first part is fairly easy. We always just write the name of the metal. Okay, just write down the name of the metal. And then to the non-metal, we change it by adding IDE to it. Okay, so instead of, for example, chlorine, you might have chloride. Instead of fluorine, you might have fluoride. Instead of carbon, you might have carbide, okay? And so basically that's all you have to do. Just write the name of the metal and then put IDE on the non-metal's name. All right, so for example, if we had this compound NaCl, we know the metal is the first one. That's always written first, so sodium. And then this is chlorine, so we're going to put IDE on it, so it would be called sodium chloride, okay? And so we would type that in, that would be sodium chloride. You need to write that down, but I did not have it on my chart, okay? So that is sodium chloride, all right? Now, other elements that you might use, okay? Sulfur, well, it doesn't have an INE on it, so it's not as easy to do as chlorine, but you just put sulfide. All right, fluoride is fluorine, iodine is iodide, oxygen, once again, we don't have an INE on the end, so we have to change it up a little bit, but that's oxide. We've heard of oxide probably a lot. Carbon dioxide means there's 2 of them. Okay, bromide, bromine, just change it to N to a D, and nitrogen is nitride, okay? And so these are just some of the examples of elements you might see non-metals on the other side. The nice part is there's not very many non-metals, so we don't have to learn a whole bunch of them, okay? But anytime you see IDE on a word, you know that there's 2 elements, and the one with IDE on it is probably a non-metal, all right? So sodium chloride tells you that you have a sodium atom and a chlorine atom joined together. So that's the first rule. If you have a metal and a non-metal, then that is how you would name them. All right. Compounds that are made of 2 non-metals. Oh, and that's a little different, okay? Now, in this case, someone says you have 2 non-metals. I thought they wouldn't be attracted to each other, and that is correct. They would not be attracted like the positive and negative of a metal and a non-metal would be. However, they can join together if they share electrons. If you remember, non-metals like to gain electrons. Well, sometimes if one atom needs an electron, the other one needs one, they will share that one electron. And so some of the time one person has it, some of the time the other person has it. Share and share alike, okay? So they'll very politely play nice with each other and share, okay? So naming it is very similar to where you have a metal and a non-metal. you still write the name of the first element, which is a nonmetal, all right? And then you're going to put IDE on the second one, all right? However, a difference is many times there are different versions of it. For example, there's CO, all right, and there is CO2. Where am I here? Okay, so for example, CO and CO2. Well, if we just did the name where it said carbon, the first one, and put IDE on the second one, that would be carbon oxide. But this one would also be carbon oxide. So to tell them apart, we actually put carbon monoxide. Mono or mon means one, and di means two. So this is carbon dioxide. Okay, so sometimes we will put a prefix on, especially if there's more than one atom, but sometimes even when there's one atom, since there's a CO and CO2 are very common, they both have a separate name there. Okay, so we put a prefix on them to tell how many oxygens are stuck onto it. All right, and just so you know, di means two, so this would be carbon dioxide up here that we talked about. Okay, just for the record, say we had CO3, which we're not, there is no compound, not a neutral compound with that, but that would be carbon trioxide. Okay, if there were four, then it would be called tetra. For example, this compound C, oops, sorry, CCl4. Mr. McMurray's drawing skills are not good here. Okay, you have one carbon and you have four chlorines, so this is carbon tetrachloride. Tetrachloride just tells you that there's four of them. That's not as common, but it's possible. You could even have penta, which would be five, so pentachloride would have to have five chlorines, and so on. Okay, and so the example we gave down here is carbon, so you'd write down carbon, and then you would put tetrachloride. Okay, so it's going to be carbon. Oops. Mr. McMurray's writing skills have gone completely downhill. All right, so that is carbon, and then it would be tetra. All right, and then it would be chloride. All right, I'm just going to put the ID on the end here. Okay, I'm sure you can write that down much better than I did. All right, carbon tetrachloride. All right, and that's basically how you would do that. Now, next one, getting a little more complicated, is compounds that have three elements. Now, usually they will have a metal that's a positive, and then they'll have a couple of nonmetals joined together, and one of the nonmetals will usually be oxygen. Okay, so for example, carbon, we said over here, you could have three oxygens on it. Whoa, carbon with three oxygen. The problem is it's not going to be neutral. It's not a compound. Compounds have to balance each other out, which we'll talk more about later. But this is going to be carbonate ion, what we call a carbonate ion, because it has a charge, okay? But it has two nonmetals joined together, and one of them is oxygen, okay? So this is a very common situation. All right, so you have metal plus a nonmetal plus oxygen, okay? Now, we could just say, for example, let's just say we had this one here. We would have Ag, which ain't gold, so that means it is silver. Very good. And then we have nitrogen with oxygen. Okay, we could call it silver nitrogen oxide. Okay, but to make it a little bit shorter and less of a mouthful, instead of having three parts to it, to show that there's an oxygen attached to it, we just put ATE on the nitrogen. Okay, so instead of typing that all out and having three names, we're going to say this is silver. Okay, and I'm not going to write that whole thing out because you know how that is. And we're going to call it nitrate. which when you used to have long distance phones was much better to call because the night rates were much better than the day rates. You know, they're probably too young to remember long distance, but there was a time when it cost a lot of money to call people at night, or during the daytime it cost more, and night rates were always a lot cheaper. But anyhow, silver nitrate, okay? Now, some other examples of compounds like this, if it's sulfur with oxygen, then it would be sulfate. If it's phosphorus with oxygen, it would be phosphate. Carbon with oxygen stuck to it would be carbonate, and so on. You could have chlorate, you could have fluorate, you could have bromate, okay? But sulfates, phosphates, carbonates, and nitrates tend to be the most common ones, so that's why we put those up there. But there are some others, just so you know. All right. Now, before we go on to the C, let me give you one other thing up here, okay? Okay, you may also see some that have endings like I, T, E. Whoops. Sorry. Okay. I, T, E. So, for example, nitrites. Nitrites, you may have heard that before when people have lunch meat, things like hot dogs and salamis and stuff like that. They have a lot of nitrites in them, and nitrites in this case are harmful preservatives. Okay, they keep the meat from spoiling. That's the good news. The bad news is they have been possibly linked to increasing cancer. Of course, eating rotten food is not exactly healthy for you either. So it's allowed, but a lot of places are getting rid of the nitrites. I've noticed some lunch meats lately saying they don't have them. But yeah, if you see nitrite, it's going to be just like this one, but with one less oxygen. So it'd be AgNO2. Okay. All right. So if you see an NO2, it would be a nitrite. Okay. Now, we won't worry about that too much. If we see an oxygen on the end, we're going to assume it's an 8. To be honest, in chemistry that we use, 8s are a lot more common. The ites are around, and you will see them on the ingredient list of things and stuff like that, but you don't see it as much. But if you had sulfite, then guess what? There would only be 3 of these. Or if you had phosphites, there would only be 3 oxygens. Or CO2 would be carbonite. I'm not really sure there is a carbonite, to be honest with you. But anyhow, if you see ITE, don't panic. It just means it has oxygen, just one less. All right? All right. Now, the next one is you have a compound with 3 elements. One of those is a metal, once again, and you have OH ion, which you'll notice has a negative charge, okay? And so it's going to be a -1 charge. All right? And so we're going to put these together. It's going to be fairly simple. For example, here we have NaOH, okay? Once again, we're going to write the name of the metal. Notice we always write the name of the metal, all right? So Na is... exactly. Sodium, okay? Sodium, and then OH is going to be called hydroxide, okay? Sometimes it's also called a hydroxyl with a YL on it, but when we name it, it's hydroxide. So this one would be called sodium and then hydroxide over here. That's all you got to put, okay? So it'd be sodium hydroxide, all right? That would actually be Drano. Very serious stuff. When we put the sodium in the water, that was basically sodium hydroxide, a very strong base used to clean out people's sinks and clogged drains and stuff like that. All right. All right. Now, the last section is a little bit different. Compounds that start with an H at the beginning are often acids, and they have kind of their own set of rules. So they don't follow the simple rules we have done here. Okay. But they will still work, okay? HCl, according to our rules, if that was a metal and a nonmetal, we would name it for the hydrogen, okay? So we'd say the hydrogen right there, and so we'd write that name down, and we put IDE on that one, which is hydrogen chloride. Well, turns out that it's called hydrochloric acid, okay, because it has kind of a different rule for naming it. But if you talked about hydrogen chloride, people would still know what you're talking about. And so using our basic rules will still get you there. H2SO4 is sulfuric acid. Got nitrate on the end of it. That'd be nitric acid. Notice water can be written as HOH, which means it's like an acid with a hydroxide on it. So hydrogen hydroxide would be water. Okay, and if you call it that, people would know what you're talking about. All right, so those are basically the